What's up, guys? Welcome to Calculus Club. In this video, we are going to be talking about the intermediate value theorem, okay? And I think you're gonna find this to be a pretty easy theorem, actually. But I'm gonna explain it in the next slide. So let's get into it. So the intermediate value theorem just essentially says this. If a function is continuous, like this blue function here, okay? If a function is continuous from a to b, then you can take any number you want between f of a and f of b, right? So we take n, and there must be some value c that lies between a and b such that f of c equals to n. All right, that's it. So it just pretty much says that if I'm continuous from f of a to f of b, well, obviously I need to pass through n in order to get to f of b, right? So it needs to be a continuous function. As I've mentioned, your n is between f of a and f of b, and there exists a c between a and b such that f of c equals n. That's the intermediate value theorem. The important thing is the function must be continuous, okay? So let's do an example. So we're gonna use the intermediate value theorem to show that this function has a root, which is where y equals 0, right? Also called zeros. Y equals 0 on the interval 0 to 1, okay? Now the first thing is we need to establish that it's continuous. Now this is a polynomial, x cubed plus 2x minus 1. And all polynomials are always continuous, okay? So we know it's continuous everywhere. For this particular problem, we only need to be sure that it's continuous between 0 and 1, but we can also say that it's continuous everywhere. Therefore, it's also continuous between 0 and 1, okay? So how do we do this? Well, what we're gonna do is we're gonna find f of 0. So when I plug in 0 here, I get 0 cubed plus 2 times 0 minus 1, so f of 0 is negative 1. And I also want to calculate f of 1, okay? So that's 1 cubed plus 2 times 1 minus 1, which is 1 plus 2 minus 1, which is 2, okay? Now the idea here is that f of 0 is negative 1, f of 1 is 2, so therefore 0, y equals 0 lies between negative 1 and 2. Therefore, there must be some value c between 0 and 1 such that y equals to 0, okay? And here's the graph, okay? This is 0 and this is 0 and 1, so 1 is here, 0 is here. So this number is here. We're not actually going to solve for that number. We just know that that value c exists. There must be a value c. So, but yeah, we can do that real quick, right? This is a quick video. So let me just go ahead and open up Desmos. Okay, so if we graph this function on Desmos, y equals x cubed plus 2x minus 1, I believe, x cubed plus 2x minus 1, that's correct. All right, we can zoom in here. We'll zoom in really far. So we know that here's 0. Is that the right one? X cubed plus 2x minus 1. Ah, yeah, okay. So, sorry. So this is 1 here. This is a half, not 1. Okay, so between here and here, then we definitely have that value c. Okay, so back to Desmos. There's our value 1, which is, if I can find it. Oh, we already found it, right? It was what? 1, 2. And we can find this 0, which is here. At c equals 0.4534, we have y equal to 0, okay? Just wanted to show you that. But a lot of times the intermediate value theorem, they just want you to prove that it exists. You don't always need to find it, okay? And that will be the most common case when you use the intermediate value theorem, is to prove that there's a root, but you might get something slightly different. Okay, so let me show you the entire intermediate value theorem as it would be written in a mathematical book. Okay, first of all, this is an existence theorem, and you're gonna see a few existence theorems within calculus. So what it does is it guarantees the existence of something as long as certain conditions are met. What are the conditions? Well, the only condition is it just needs to be continuous between A and B, okay? So the whole thing says this: as long as f of x is continuous, that intermediate value theorem guarantees that there is a c between A and B such that f of c equals n is a y value between A and B, okay? So here's A, here's B, here's n, so we know there must be a c. Now, the last thing I want to mention about this is there can be more than one c, right? So this could go like here, like let's say the function was here, and then it goes up there, and then it goes down to b. Well, in this particular case, let me erase these c's so we're not confused, we have a few different c's, okay? So there's a c here, right? Here, here, and here. We actually have three values. We'll call this C1, C2, and C3. So f of C1, f of C2, f of C3 all equal n. So you can have more than one. The IVT just guarantees us the existence of at least one. All right, and you can generally abbreviate intermediate value theorem to IVT within a calculus class. They'll know what you're talking about. All right, so that's it. That's all there is to the intermediate value theorem. Nothing very complicated. So yeah, I hope that this video was helpful and you tune in for the next one. All right, bye-bye.